Today I will discuss about the chapter in the class 12 chemistry, organic chemistry is carbonyl chemistry. This chapter is carbonyl chemistry, and where we will found the preparation, chemical property and reactions. So first we come to what to read. We should read here the preparation or synthesis of the carbonyl compounds, chemical properties and the reaction of the carbonyl compounds. Carbonyl compounds are mainly such organic compounds specifically have the CO double bond in this compound. So carbonyl compounds are two types. One is aldehyde, which has the group formula CHO, and the ketone where the group formula is C double bond O. Here the structure is given below for aldehyde, and there is ketone. Next slide. The preparation of the carbonyl compound. We can prepare the carbonyl compounds in various ways, like oxidation, reduction, etc. The first is oxidation of alcohol. We get the carbonyl compounds from oxidation of 1 degree of primary alcohol. We will get the aldehyde after on mild oxidation. If we do hard oxidation or harsh oxidation, we will get the carboxylic acid. From secondary alcohol or 2 degree alcohol on mild oxidation, we will get the ketone compound. From tertiary alcohol with mild oxidation, we will get the ketone compound. The following reagents are given below. It is the first reagent is chromyl chloride in pyridine, which is called PCC. Then the second is AlOBF3 in acetone. And then third is Jones reagent, that is chromium oxide and H2SO4. The fourth is PCC pyridine and chromium chloride and HCl. The first is pyridine chlorochromate. Fourth is PCC, that is pyridine, chromic oxide and HCl, and fifth is the neutral KMnO4. These five reagents do mild oxidation of alcohol to ketone. We can prepare carbonyl compounds from alkene also. We can do ozonolysis of the alkene compound to get the aldehyde or ketone compounds. If there is presence hydrogen, then we get aldehyde here. If there presents all the alkyl group, then we will get the fully converted ketone compound. From alkyne we can get also carbonyl compounds by oxidation with ozone. The ozonolysis will give the ketonic compound from also from alkyne. Properties. Carbonyl compounds are liquid generally for aliphatic, those who are aliphatic, but many solid compounds are known which are aromatic. They have high dipole moment due to the presence of the CO double bond. And fourth, the liquids have the low boiling point, as their presence only the dipole-dipole interaction between the molecules. It is the carbonyl group. Here del plus charge appears and del minus charge appears on the oxygen atom, and the dipole moment is around 2.7 diopter. And for this, carbonyl compounds are polar compound, and it has about 40 to 50% ionic character. Chemical properties. The carbonyl compounds are unsaturated, and they only show the addition reaction into the CO bond. Both the electrophilic and nucleophilic additions occur here simultaneously. The nucleophilic addition to an electrophile occurs, and then the nucleophilic attack to the electrophilic carbon center occurs here. Here the nucleophile and electrophile simultaneously present, and in presence of catalyst they adds simultaneously into the carbonyl group. The hybridization of the carbonyl compound changes from sp2 to sp3. The electronic and static factors both mutually operates on the addition reaction in carbonyl bond. The presence of plus I minus R groups also influence the such addition reaction. The presence of polarity of the medium also influence the addition reaction here. Order of reactivity. Aldehydes will have always the more reactivity than the ketonic compounds, and aliphatic aldehyde will have higher reactivity than aromatic aldehyde, and aliphatic ketones have higher reactivity than aromatic ketones. These are the order. First is formaldehyde here, which is highly reactive. Then on addition of R group and AR group, the order is given here. It is the decreasing order of the reactivity. The presence of the conjugation system also reduce the reactivity here. The presence of conjugation system, that is the double bond at alpha carbon and beta carbon, it will reduce more reactivity of the carbonyl compound. Reaction. Addition of water. Addition of water does not occur generally both in presence of acid or base catalyst, but there is a point that water addition, if water is used instead of if water that if here water containing O18 group is used instead of normal water, we will get that there occurs exchange of OH group here. There occur H2 addition reaction when the carbonyl compound contains some special groups which can stabilize the hydrogen product. That is, first example is chloral. The chloral, if H2 is added, then it will form the chloral hydrate, stable chloral hydrate. It is due to the presence due to the interaction generation of the hydrogen bonding interaction here. Then the next compound is Indian 1,2,3 trione, who will also form hydrate due to the formation of the hydrogen bonding here. The next reaction is addition of alcohol. The addition of alcohol to aldehyde will give hemiacetal and acetal. In hemiacetal, one OR group, that is one alkyl alkoxyl group will added, and in acetal there will be two alkoxy group will add here. And for ketonic compound, the RH group will added. If one single OR group is added, then it will produce hemiketal, and if two OR group is added, then it will form ketal. Addition of alcohol is generally in presence of acid catalyst. The products are stable but unstable in presence of water. The products are stable in concentrated sulfuric acid also. It is the mechanism given here. Why the formation of the acetal or hemiacetal, ketal or hemiketal is acid catalyzed, purely acid catalyzed reaction. Here it is given. Then addition of thiol, it is like alcohol, it will produce hemithiol or hemithioacetal or thioacetal, hemithioketal or thioketal. The addition of ROH occur generally in presence of acid catalyst. The products are more stable than the acetal or ketal due to the presence of the sulfur. The addition of ROH also occur generally in presence of RSH. It will be not ROH, it will be RSH, occur generally in presence of base catalyst, but it gives only hemiacetal or hemiketal like product. Next reaction is addition of 1,2-diol or 1,2-thiol. 1,2-diol or 1,2-thiol also added to form the cycloacetal or cycloketal. Cycloacetal or cyclothioacetal, cycloketal or cyclothioketal. The cyclic products are stable than the acyclic product also. The thioacetals can give its color and they then give its counter stable anions. It can give you in presence of base. If we use a strong base in presence of into the thioacetal, it will form a stable anion, and with this stable anion we can generate some nucleophilic addition reaction into various electrophilic centers. NH2Z type reaction. Z is the various ligands which is attached to the NH2. In NH2Z type reaction, the aldehyde or ketonic compound will combine with the reagent, and it will lose one molecule of water and give a addition product imine. The products are stable in presence of acid or solid state. The products are quite unstable in dilute acid. The most of the products are solid in nature. The NH2Z type reagents are hydrazine, N2H4, the hydroxylamine, NH2OH, the semi-carbazide reagent NH2CO, NH2NH2, and 2,4-dinitrophenyl hydrazine or 2,4-DNP. This is the structure of NH2. These are 4 prominent NH2Z type of reagent in carbonyl chemistry. Then comes to the Wittig reaction. The Wittig reaction is carried out in presence of the phosphonium ylide reagent with carbonyl compounds. It will give the alkene as a product. So we can prepare alkene from the carbonyl compound by Wittig reaction. The reduction reaction of carbonyl compounds. Carbonyl compounds can be reduced to alkane, or it can be reduced to alcohol. If we use the lithium aluminum hydride or lithium borohydride or sodium borohydride or MPP reagent, it will produce alcohol as a major product. So activity order of the reagent is lithium aluminum hydride is greater than lithium borohydride and greater than sodium borohydride. The Ullquistner reagent, if we use Ullquistner reagent, it will, or Clemenson reagent, if we use the Ullquistner reagent or Clemenson reagent, it will produce a CH2 group here in presence of the in the position of the carbonyl compound. The Ullquistner reagent is hydrazine in presence of alcoholic KOH, and in Clemenson reagent the reagent is zinc Hg, zinc amalgam in presence of HCl. These are the reagent of this reduction reaction. Another reduction reaction in the alpha beta unsaturated ketone compounds. It is the cyclic ketonic compounds. If we use the lithium aluminum hydride, it will reduce the all 2 types of bonds here. The carbonyl bond, C double bond O bond, and the C double bond C bond will be reduced to form the alcohol as a compound. And if we use the NaBH4, some less reactive reagent, it will only reduce the carbonyl compound but not the double bond here. If the carbonyl compound is reduced with aluminum isopropoxide in presence of isopropyl alcohol, which is called MPV reaction, Miarwin-Pondorf-Verley reaction. So it will produce also the OH alcohol group. So in this reaction, the prominent feature of this reaction is that the unsaturated double bonds will not be reduced here, only the carbonyl groups will be reduced here. In Clemenson reduction, the zinc HgHCl is reagent used to give the CH2 group in presence of CO group. And for Uhl-Kirchner reagent, the KOH in presence of NH2 will give the product as alkane. Next come to aldol reaction. It is a condensation reaction of the carbonyl compound having alpha hydrogen present on the alpha carbon. The molecules of carbonyl, two molecules of carbonyl compounds having alpha hydrogen present on the alpha carbon with each other in presence of strong base. So this is the carbonyl compound. Here the alpha, beta, gamma and delta carbons are represented, and the alpha carbon here showed is more acidic, and the alpha carbon here shown as less acidic. Due to here is present an alkyl group, there is no presence of alkyl group. No, this will be more acidic, and this will be less acidic. Actually this will be more acidic, and this will be less acidic. So in presence of dilute NaOH, the acetaldehyde will combine with another molecule of acetaldehyde to give an alpha beta unsaturated carbonyl compounds. Here the ketone, the oxygen atom of the ketone group and the CH3, the two hydrogen atoms from the CH3 will combine with each other, and a condensation reaction with the elimination of the water molecule will give the alpha beta unsaturated carbonyl compound. This is called the aldol reaction. Then comes to Michael addition reaction. It is the addition reaction of the alpha beta unsaturated carbonyl compound. Sometimes it is called the 1,2 addition via 1,4 process. So if we add HBr, the HBr will be added directly to the double bond through 1,4 addition. So first the proton will be accepted with the carbonyl oxygen atoms, and from the enol, from the bromo alpha beta bromo enol as intermediate products, which will give the ketonic compound. This is the HBr addition. And if we add another nucleophile and electrophilic addition simultaneously, the electrophile would add into the 3 position, and the nucleophile will add it into the 4 position. This is called Michael addition. That is 1,4 addition into the alpha beta unsaturated ketone. Next come to Cannizzaro reaction. This is a special type of condensation type reaction. Here more concentrated NaOH, that is 50% NaOH or KOH, is used in the refluxing condition. Here the carbonyl compounds, the feature of the carbonyl compound is that the carbonyl compound does not contain any alpha hydrogen. There can be presence of alpha carbon, but there should not be any alpha hydrogen there. The first example is formaldehyde. If we do Cannizzaro reaction, then with the formaldehyde, the one molecule of formaldehyde will be oxidized to its salt of formic acid. This is the salt of the formic acid. One molecule is oxidized and the another molecule is reduced to the its primary alcohol. This is the Cannizzaro molecules, Cannizzaro reaction. Here is a reaction given aldehyde, acetaldehyde and 4 mole of acetaldehyde and 1 mole of ACHO. Here the first there will be aldol reaction. First there will be aldol reaction with the 4 acetaldehyde. Then at last there will be Cannizzaro reaction with the CHO group, ACHO group, formaldehyde with the formaldehyde to give the penta erythritol as a compound, Cannizzaro product, as a Cannizzaro product. Next come to the Parkin reaction. Here also carbonyl compounds, aromatic carbonyl compounds. Here presents aromatic aldehyde in presence of acetic anhydride, in presence of acetic anhydride, and in presence of sodium acetate as a base. It will give an alpha beta unsaturated carboxylic acid compound. This is the alpha beta unsaturated carboxylic acid compound. The condensation reaction of two molecules of aromatic aldehyde in presence of the KCl. This is the benzoin condensation. Next reaction is the benzoin condensation. Here aromatic aldehyde is reacted with the KCl in presence of alcohol. It will give the benzoin condensation reaction to form a benzoin here, and on oxidation with HNO3 it will give the benzyl as a product. The Parkin reaction. Parkin reaction, 2 moles of sodium ethanoate will combine with each other to give such type of product. And in Novinogall reaction, active methylene compounds are also used. Carbonyl compounds along with active methylene compounds in presence of solvent will give the Novinogall product. These active methylene compounds are like this: malonic ester. Malonic ester is active methylene compound which will react with the carbonyl compound in presence of piperidine base, will give the Novinogall condensation reaction. Next come to the halogenation reaction. Halogenation reaction can occur in presence of acid catalyst or in presence of base catalyst also. The carbonyl compounds should have the alpha hydrogen in its alpha carbon. This is acid catalyzed through stable enol formation. Acid catalyzed reaction will passes through the stable enol formation. It will give one halogen group to be attached with the alpha carbon. And in base catalyzed reaction, there is a possibility of further substitution into the alpha carbon. In base catalyzed halogenation reaction, finally we will get the haloform as a compound. If we use halogen in presence of NaOH, it will give the haloform as a main compound of this haloform reaction. Next come to the Tischenko reaction. From the with this reaction we can get the ester. We can ester from the two molecules. We can get the ester from the two molecules of aldehyde which are particularly have alpha hydrogen. It is the feature of this reaction. The carbonyl compound can have the alpha carbon and there can have the alpha hydrogen here, and we can get the ester as a compound. in Tischenko reaction. The reagent is aluminium ethoxide and heating is used. In pinacol reaction we use magnesium amalgam and concentrated HCl, and it will react with the carbonyl compound to give 1,2-diol, which is called as pinacol. And the pinacol, if we use the concentrated sulfuric acid, it will give the pinacol rearrangement product. It is called pinacolone. It is called pinacolone as a product. Next, come to beer vinegar oxidation reaction. With this beer vinegar oxidation reaction, the per carboxylic acid, that is like MCPBA CF3C2H, is used to make ester from the carbonyl ketone compound. The ester is formed in this reaction. The cyclic ketone compound will give cyclic ester or lactone compound in presence of this beer vinegar oxidation reagent. This is the reaction mechanism. This reaction passes through a cyclic transition state followed by the alkyl migration. It will give the ketone ester compound as a product. Next, come to alkylation reaction. Alkylation reaction can occur here into the alpha carbon atom of this ketonic molecule. It can be alkylation can be acid catalyzed, or alkylation can be base catalyzed. So base catalyzed alkylation will give such type of product, and acid catalyzed alkylation will give such type of products here. In acid catalyzed reaction, this substitution of the product is measured, and for base catalyzed reaction, and this substituted product is measured here due to the different mechanism followed by the participating reacted molecules. Here alkylation reaction can process through or Stark-enamine reaction like this. This is the major product here, Stark-enamine reaction. This is the major product, 1,2-dialkyl ketone compound, and this is the minor product. This is Stark-enamine. The reaction actually passes through the stable enol intermediate or enamine intermediate. More substituted enamine is more stable, thus it will be the major product. 1,2-dialkyl ketone will be the 1,2, not, it is not 1,2, it is 2,2-dialkyl. It is actually 2,2-dialkyl ketonic compound. Next, come to the Dargent glyceric ester. The alpha halo carbonyl compound and ketonic compound in presence of NaOT as strong base, it will give the Dargent glyceric ester. Here it is the Dargent glyceric ester. It is epoxide and containing ester. So it is the end of the class. Thank you everyone. Okay.